Hello.
Okay, can you hear me?
Mm.
Okay, right. So today we are going to sketch a quadratic function. So this quadratic function is a function that looks like this. It has x squared, x, then followed by a number, right? So on the left-hand side, it can be fx, gx, or you can call it y. So as long as there are two variables, then you can plot the graph of the function. Okay. So again, quadratic function must have y on the left-hand side. It cannot be equal to 0. Or if it is equals to 0, it is not a function. It is a quadratic equation. So you have to need to have a y or fx or gx on the left-hand side. Then on the right-hand side, you will have a x squared plus bx plus c. So it means that you must have a x squared, you must have x, then you must have a number. Then in front of the x squared and the b and the x, there is a and b, which represents any number. It can be any number, but not 0. If a is 0, then there is no more quadratic term there. So this equation is no longer a quadratic function, right? So there's no, a cannot be 0. Right? So this is the general form of a quadratic function. So I must say it is a quadratic function, right? Ax squared bx plus c. Now, however, if the equation is given in this form, it is not very useful, not very useful. Right? I will explain later why it is not very useful this way. Right? We look at another form of the quadratic equation. So another form will be a bracket x plus h square plus k. Now this form is completing the square. I don't say perfect square. Not a perfect square. It should be completing the square, right? Completing the square, right? In order to get this form, you have to complete the square. So let's say this form is completing the square. Again, what is the form? How does it look like? There must be a bracket, then square. Inside the bracket, there is a number. In front of the bracket, there is a number. And there is another number plus another number behind. So this form is actually obtained by completing the square. Okay, right. Now, each of these forms, they have their own usefulness. Now, in this form, ax squared plus bx plus c, you can actually see the y-intercept from the equation. The c is the y-intercept. Another usefulness of this form is you can actually equate this to 0, make the y equals to 0, or make the fx equal to 0. Then you can obtain a quadratic equation. By solving this quadratic equation, you can actually find the x-intercept. You can actually find the x-intercept. So this form, the general form, ax squared plus bx plus c, has two uses. The first one is to find where it cuts the y-axis or the y-intercept. Another one is to find where it cuts the x-axis or the x-intercept. So this form is like that. So I read. Now this is the general form. Ax squared plus bx plus c is called the general form of a quadratic function. How does the shape of the curve vary with the values of the parameter A, B, and C. Now, if you are going to draw the graph of the quadratic function, or if I change the values of this A, how will the shape of the curve, how will the shape of the curve change? If I change the value of B, how will the shape change? If I change the value of C, how will the graph change correspondingly? Okay, so there is the first question. In other words, this A, B, and C, how can they control the shape and the position of the curve? Okay, this A, B, C, how they control the shape and the position of the curve. So this is what they want. Number two, how does the position of the curve vary with the value of b squared minus 4ac? Now, this b squared minus 4ac is actually called the determinant. So this determinant will decide whether the quadratic function will cut the x-axis or not. If this quadratic function, it doesn't cut the x-axis, I mean the x-axis is here, the curve is above, so it will not cut the x-axis. Or the curve is below and the x-axis above, they will also not cut the x-axis. So this b squared minus 4ac actually determine whether the quadratic function will cut the x-axis or not. How about the y-intercept? Y-intercept is controlled by this number c. I will show you graphically later on how it is controlled by this number c. What is the x-intercept? Now, the x-intercept is actually the roots of the quadratic equation when fx equals to 0. Now, in this form, it is not an equation. It's not an equation. It's called a quadratic function. However, if you put this fx equals to 0, then this whole thing becomes a quadratic equation. So the roots of this quadratic equation is where the curve cuts the x-axis. Okay, right? So I've told you so many things, but we have not seen the graph. So I'm going to show you this graph, ax squared plus bx plus c. Okay, right. So this is a quadratic function. The value of a is this. The value of b squared minus 4ac is. Now, let me make it simpler. Huh? Let's say the value is 1. Huh? The value is 1. Okay? How to make it 1? This is 2. 1. How to make a value of 1? Ah, this is the value of a is nearly 1. Okay, so let's say this value of a is 1. So that means there's no number in front, right? Then the value of b, how the value of b? If the value of b is a positive number, then it will dance to the other side. If the value of b is a negative, then it will dance to the other side. So how is it related? We cannot actually see from the graph. We only see that they move from the positive side to the negative side and so on. So another thing is this one, the value of c. Value of c is very clear. The value of c is where the curve cuts the x-axis. Let's say c equal to 1. Yeah, c is cut at 1, the c equal to 1. C equal to 1. Let's say c equals to 2. Pull it until 2 here. C equals to 1.9 something. So you will cut at 1.9 something. Let's say I put C equal to 3. So this is exactly 3. And you see that the curve cuts at 3. And I make it, let's say, 6. 6. Okay, the value of C is 6. And you see that the curve cut at the y-axis at 6. So that means the value of C here is actually the y-intercept. Exactly. Whatever the value of C here, that is the y-intercept. Just like our linear equation, right? Just like our linear equation, y equals to mx plus c, right? So if the c is actually the y-intercept. This B not very B positive, then it will be somewhere on the left-hand side, then it will start to grow, right? Not this B equal to 1. Okay, then the value of A, value of A, this is 1, Let's say if it is smaller than 1, you will see that the curve is fatter, Let's say I make the C come down. Okay, let's say the value of A becomes 1. Then the graph is more pointed. Let's say the value of A is 2. Oh, it becomes sharper, more pointed, right? If the value of 3, let's say, value of A becomes 3, become more and more pointed. So we see that if the value of A is bigger than 1, then the graph is become very thin, very thin. Now, let's say if the value of A is less than 1, this is 1, less than 1, the graph become very, very rounded, not very pointed, but very rounded, wide, spread out widely. How about the value of A become -1? The value of -1, the curve becomes inverted, like the N shape like that. If it's positive, then it is the U shape. Okay, so let's say I make the more negative, -2. So it is still inverted, but it becomes narrower. Let's say I make it -3. Right? -3 is inverted and become narrower. So as I increase the value of, not increase, this one decrease. As the value gets like that, the modulus of the number become bigger and bigger, then the curve becomes more and more pointed. One more time. Let's say I reduce the value of A, become thicker and thicker here. If it is between 0 and, between 1 and -1, it's become very fat. If it's positive, then it will be U shape. If it is negative, then it is the N shape. If it is U shape and very, very big, the number, the curve becomes very, very pointed, very, very pointed. Now, if the number becomes smaller and smaller, the curve becomes wider and wider and more rounded. So, two things we can see from this quadratic equation: ax squared plus bx plus c. Number 1 is the value of A, and number 2 is the value of C. So we can actually determine the shape of the curve by looking at the value of A and C. But we only know the shape, whether it's U shape or N shape, and where it cuts the x-axis. That's all. Y-axis. That's all. Now, if you want to know where the curve cuts the x-axis at these 2 points, you have to actually solve the quadratic equation and find out the roots of the quadratic equation. Okay, there are 2 roots, x1 and x2, here and here. But if the curve is above the x-axis, then you see that there will be no roots. because this curve, it doesn't cut the x-axis anymore. So there will be no roots. There is no x-intercept. Now, if the curve is like that, so we can see there are 2 points of intersection, one here and one here. One here and one here. Okay, so these two, they are the x-intercept. How to find the x-intercept, this point and this point here? You have to solve the quadratic equation. I have solved the quadratic equation. I see now is the first number is 2.59. You see, this is 2, this is 2.5, this is 2.59. The second number is negative 5.26. This is negative 4, this is negative 5, this is 5.26. So sometimes the curve will cut the x-axis. How to find these 2 points? You have to solve the quadratic equation to find these 2 points. Sometimes the curve is above this is the x-axis. The curve is above the x-axis. There is no root for the quadratic equation, so undefined. Okay, so this is for the positive type of curve. Let's say if the curve is negative. Let's say if the curve is negative. Okay, we see that even though it's negative, sometimes it will cut the x-axis here. Okay, so there are two answers. The intercept on the x-axis or the x-intercept, there are two numbers, and the two numbers are here. Now, let's say if I move this curve down, now it cuts at 1 point something. Let's say I move the curve down. Or the curve now cuts at 3. Cuts at 3. Cuts at 3. So this purple curve, it does not cut the x-axis. So there's no root for the quadratic equation if it's below. Sometimes it's above. If it's a U shape, above, no solution. If it is the N shape, below, there will be no solution. Now, in order to produce solution, let's say the curve is higher, like that. If it's higher, then they will cut at 2 points. If it is lower, the curve is lower, then they won't cut the x-axis. So whether there is x-intercept, or we call it the roots of the quadratic equation, whether they are roots or not, it depends on the position of the curve. It depends on the position of the curve. Anyway, we have learned two things from the parameters A and C. So can you tell me what does C represent? Ax squared plus bx plus c. What does C represent?
Intercept.
What intercept is that?
Y.
The y-intercept. Okay. What does the A represent? A represent what now? This is A. The A. This is the A. What does the A represent? What if A is positive? What if A is positive?
A positive and the child positive.
What can you tell if A is positive? This is A positive. This is A negative. Negative. This is negative. This is
If
positive.
positive is U shape.
Positive is what?
U shape.
U shape. Negative,
N shape.
N shape, correct. So if you just look at the ax squared plus bx plus c, you can imagine how is the shape of the curve already, whether it's U shape or N shape, number one. Number two, whether it is where it cuts the x-axis. So you can see two things from there. Okay, now? Now whether
Yeah.
it cut the y-axis, the x-axis or not, you have to solve the equation. Do you know how to solve the quadratic equation using the formula?
Yes.
Okay, so you can use the formula to solve the quadratic equation. Once you solve the quadratic equation, the two values of x, they are these 2 points where it cuts the x-axis. So that's how what you can get from this ax squared plus bx plus c. Okay, right. Now let's say I have this equation here. What is this? Just copy this. Okay, so let's say this is a quadratic equation. I expand this, expand it, or maybe we call it fx first, fx first. Okay, I
Yeah.
expand this fx equals to, when I expand this will be x squared minus 6x plus 9. Then this one is minus 4. So I simplify this. This will be equal to x squared minus 6x. This one will be plus 5. Eh, Plus 5. So looking at this quadratic equation, can you tell me a quadratic equation or quadratic function? Can you tell me what is the y-intercept?
5.
Correct. Y-intercept is 5. Can you tell me what is the x-intercept? What is the x-intercept?
E.
X-intercept, we have to put fx equals to 0. If fx equals to 0, it means this one equal to 0. So if this is equals to 0, then you have to solve the quadratic equation to find what is the roots of the quadratic equation. Okay, so we find the roots of the quadratic equation. X minus 5 equals to 0. X equals to 5. So I know the x-intercept is 5. Another one, x minus 1 equals to 0. So I know another root of the quadratic equation is x equals to 1. So I know if I have the curve, if I want to sketch the curve, okay, I will sketch the curve like this, and this is the x-axis. You will cut here at 1, you will cut here at 5, okay? Because the x-intercept is 5, and the x-intercept is 1. Now, this quadratic equation, that you will cut the y-axis. This is the y-axis. You will cut the y-axis at 5. You will cut the y-axis at 5. Because why? Because this one is 5. So here is 5. The C is 5. So this is 5. Then because the x equal to 5 is 1x, x equal to 1 is another one. So actually from this quadratic equation, ax squared plus bx plus c, I can know two things. The first thing is where it cuts the x-axis, y-axis, and also where it cuts the x-axis. And also because the a here is what now? Can you tell me? What is the value of a here?
5 and 1.
Huh?
5 and 1.
No, that one, 5 and 1 is this one, where it cuts the x-axis. And you can obtain by putting equal to 0. I want to know the value of ax squared plus bx plus c. The value of c is 5. So the intercept is 5. What's the value of a here in this quadratic equation? Ax squared plus bx plus c. What is the a?
Mm,
What is the value of b?
6.
Negative 6. It's not 6. What
Negative
is the value of c?
5.
Positive 5, not 5, positive 5. So what is the value of a here? You cannot see any number there.
1.
1, yes, positive 1. So because the value is positive 1, that's why the curve is the U shape. If this is negative, then the curve is the N shape. Okay or not?
Mm.
So from this ax squared plus bx plus c, you can know roughly what is the shape of the curve, where it cut the x-axis, where it cut the y-axis. This is how you can guess the shape of the curve. So coming back to this thing here, one more time, A, positive A, and the A become very big, it become very pointed. But anyway, it is a positive A, it will be the N shape. Okay. Then the B, don't know anything about the B. Then the C is where it cuts the y-axis, the y-intercept. Let's say C is 3, then it will cut at 3. Let's say C is 4, then it will cut at 4. Let's say C is negative 1, then it will cut negative 1. So you know where it cut the y-axis, you know the shape of the curve, you can roughly sketch the curve, but it's not very accurate. Not very accurate. Let's say this one. Let's say I take another one. Let's say I take this one. Let's say I take this. So from this graph, can you expand this and tell me where it cut the y-axis? If possible, you tell me where it cut the x-axis also from this graph. You expand this one, right? So when you expand this, fx fx equals to 7 minus x squared. X squared. And this one is minus 6x uh, minus 9. Minus 9. Wow, all become negative. So fx equals to fx equals to. Now, this one, so positive 7, negative 9 is negative 2. So we have a quadratic equation here. Now, can you see what is the value of A here? What is the value of B and what is the value of C?
Yes.
What is A?
-1.
What will be the shape of the
And
N shape? Then where will it cut the y-axis?
-2.
Negative 2. Now, if you solve this quadratic equation, I don't know whether you can. I think you can solve this quadratic equation and you tell me where it cuts the x-axis, right? You use your calculator. Your calculator can solve quadratic equation, isn't it?
Mm.
So you solve and you tell me where it cuts the x-axis. Then I will try to draw the graph for you. I'll try to draw the graph. You only need to tell me where it cuts the. You calculate and see. Use your calculator.
Um, come out the
What?
negative
Huh?
7.
Negative
Negative minus the punca kuasa 7
square root of 7. Then one more.
plus square root of 3 plus square root of 7.
3 plus square root of 7. Then another
Negative
one.
2, -3 plus square root of 7 and -3 minus square root of 7.
Negative 3 plus square root of 7. Negative 3 minus square root of 7. Square root of 7 is 2 point something. Okay, so this one is negative 5 point something. 5 point something. This one is negative 0 point something. 0 point something something. So now I know already. One is negative 0 point something. Another point is negative 5 point something. So I have these two roots. Then where it cut the y-axis? Y-axis is this one,
So
negative 2.
-2.
So the curve will be like this because it's the N shape now. So this one is negative 2. This one is negative 0 something. This is negative 5 point something. So now, can you draw the graph like this? Can or not? You, first of all, you look at the value of C, right? Look at the value of C, then you know where it cut. But you have to look at the A first, whether it's the N shape or the U shape.
Mm.
Then after that, you know where it cut the x-axis, you know where it cut the y-axis, then we can draw that. But sometimes you don't have one, these 2 points. Sometimes you solve the quadratic equation got no answer. So no answer then cannot be. Right? I think it's okay. So this is how you're going to draw, right? Okay. Okay, I'll clear all the drawing, then go back to this. So now you can see the usefulness of this graph, right? It allow you
Mm.
to know where it cut the x-axis, also where it cuts the y-axis, whether it's a U shape or N shape. So you can easily sketch the graph. But this is not useful because it's not very accurate. The more accurate one will be this. The more accurate one will be this. A x plus h squared. You got bracket square. Okay, there would definitely be a bracket square. Then plus a certain number, right? So this one cannot start because we have only 2 minutes left. We stop here and continue at 9 o'clock.
Okay.
Okay, we stop here.